Good afternoon, YouTube. Just doing a little bit of testing on the diversion load setup here. The diversion load on line 2 is trying to keep this side close to 0. So right now I'm burning up about 120 watts of power to keep line 2 close to 0. But I've got 97 watts of load on line 1 here, and that results in my total power is about 102. So anyway, there were 2 additional features I wanted to add to this diversion load project. One is I added a mode where diversion load 1 and 2 could help each other. So for instance, if diversion load 2 got all the way up here to 100% and this power here were still negative, that would mean that diversion load 2 just wasn't big enough to handle all the excess power. So I added a mode where if this gets to 100 and this number is still negative, I can turn on diversion load 1. So if you had maybe minus 50 watts here, I could add 50 watts here to balance the 2 out. So I call that my assist mode. And then while I was working that code up, I looked at the condition logic. And if you just change that condition around and say, if diversion load 1 is at 0 and this power is greater than 0 and you've got power you're burning up here, don't do that. Send it over here. So this down here is called a multi-switch. It's a virtual switch, and you can install this on your Vera controller. It's just an app you download, and then it gives you 8 separate switches. And what I used to do was I could turn on 2 of my diversion load items here, VSP 1 and 2. Well, I added a whole house power mode here. So watch what happens. I'll turn switch number 3 on, which enables my sharing code where diversion load 2 shares power with line 1. So this number here will go negative, and then this number here will stay the same. So I've got 107 watts coming in, 102, but look at that, I've got 101 going out. So I'm pushing 101 watts out on line 2 and bringing in 102 watts on line 1. And then look at my house power. It's down to 15 watts instead of 102 watts. And now I'm burning up much less power here. And whatever load shows up on line 1, I'm taking advantage of that to burn up the excess power on line 2. So again, that relies on a quirk of the US split phase 240 volt power system, because line 1 is on one half of a transformer winding, line 2 is on the other half, and then there's a neutral connection in the middle. But if you bring in 100 watts and you push out 100 watts, the sum is close to 0. Now right now I think a cloud just blew over. We've had a lot of clouds today. So now I've lost my excess power, and the whole house is up to 200 watts. And we can probably see that here. Yeah, I'm down to 600 watts, so I lost like 400 watts of solar coming in with that cloud. But now it's climbing back up. See, we're back up to 950, and this number here should now go negative again. So there we go, minus 152. Now that's too much because I drove the whole house negative. So now this one has to kick in and soak up some of that excess power. So yeah, it's having to chase the solar output because you got clouds blowing over. And now I think the refrigerator kicked on because that power went up. We could probably go take a look at that here. Refrigerator, yep, 117 watts. And then my grid tie is bringing in 218. So yeah, with all these varying clouds and also the varying loads, like the refrigerator on and off all day, you can't just set this up at a certain number and leave it. You have to have this control system running all day long, turning things on and off and shuffling power from this side to this side. Right now I've got a small grid tie bringing in 200 or 300 watts on line 1, and then I've got my big hybrid inverter on line 2. But ultimately I want to move this inverter with the big solar panel array over to line 1, and then I've got a second hybrid inverter with a smaller panel array for line 2. One of the issues is the inverter that will be on line 1 has about 1300 watts of panel facing due south. The array on the second inverter on line 2 has about 800 watts facing southwest. So these two inverters will get different amounts of power at different times during the day, and then likewise the loads on line 1 and line 2 are going to vary as well. Things will be on and off all day long, but the amount of power coming in here and the amount of power coming in here is dependent on the solar panels and which direction they're facing, and it may not match up to the loads here and the loads here. But with this sharing logic, if there's excess power here, I can shove it up to line 1, and if there's excess power here and I need it down here, I can push it the other way, and then whatever is not needed gets burned up. So here there's 185 watts being shuffled from one side to the other, and I'm only having to dissipate 100 watts. Yeah, I think that'll really be a powerful feature once I get the two hybrid inverters hooked up. They'll be hooked up with a parallel cable so they know about each other, but when you're in the split phase setup, you don't hook up the current sharing connection. So in the split phase configuration, this inverter will be supplying 120 volts and whatever current it can supply. This one will be putting out 120 volts, but out of phase with this one, 180 degrees out of phase, but it'll supply whatever current it needs to. But the two loads here and here may or may not be the same. If I turn on my oven, for example, that's like 2700 watts at 240 volts. So that puts 1350 watts here and 1350 here. So it's balanced. But if I run a big 120 volt load like a microwave oven or my dishwasher or something out in the shop, that load might just show up here. It might show up here. You don't know where the load's going to be, and that load may not match the amount of power available. So the idea with this diversion load logic is it can shuffle power back and forth between these two sides. Now technically the power doesn't flow from here to here. It goes out to the transformer that's out on the power pole out behind the house, and the current for line 1 comes in, but the net ends up being 0, or as close to 0 as I can get. So yeah, I just thought I'd show you that feature, and then I wanted to show you one other thing. Originally, I was trying to have a separate variable keeping track of what this load was set to. So there was the load itself was set to 0, but then I had a separate variable or a counter that was trying to keep track of this. And the problem that caused was these two, the counter and the load, those could get out of sync. By simplifying the code and just using the value that the dimmer is set to and making that a device property, I can go in here and I can mess with this. I can say, hey, 33%, something turned on. I turned on a 200 watt load, and the code comes in and says, oh, I don't like that. I'm going to get rid of that load. And you can see it did it in one cycle. You can come in here, I'll put in 367 watts, and then the code says, hey, I don't really like that number. It wants to get this down close to 0. It's still a little high here, and there it goes. It took 2 cycles to get down close to 0. So yeah, that is working really nice. So that was a really good change I made in the code. So all of those features to share the power literally are 2 lines of code. So what I have is 2 additional conditions. So this is what I call my assist mode. Basically says if the other diversion load is at 100 and the power on that other line is negative, then I compute a new increment to use up that excess power that's on the other side. And then likewise, the share code basically says if I have that switch, this is switch number 3, I call it whole house diversion load, and the other diversion load is off at 0, and the line power on the other line is greater than 0, then I compute an increment for the dimmer. So here's the diversion load new setting code. So I basically say take the existing diversion load number and then I add the increment from the regular diversion load plus the assist increment plus the sharing increment, and those all could be plus or minus numbers. And then I just say if it's less than 0, it's 0. If it's over 100, it's 100. Otherwise, that's the number. Just add those 4 things up. And you can see right there, this is diversion load 1. Works out to be 0. And then here's diversion load 2 is 33.6. So yeah, if you have any questions about that or need any details on exactly how the code works, post up in the comment section below and I can maybe do a follow-up video with some details. So hope you enjoyed that, and as always, thanks for watching.